はようございます。今日の朝のフーディニ作業配信を始めていきたいと思います。ちょっと仕事が忙しくて2日ほど空いてしまいました。今日はRBD と RBD のシミュレーションとモーヒングを組み合わせたような作例をやっていきます。はい、では動画を流します。
So to start with, we will need to create our rock. So let's go here and we drop a geo node. Let's call it rocks. Here you can see that I have 6 types of rocks. Basically, it's a sphere that may be squished, swashed.
これまためんどくさいな。これは。ちょっとぬるっと始めてしまいました。一応今回のバージョンは19ですね。最新のビルドバー号を使ってます。0.498 ですね。で、デスクトップを、動画によって割と使い分けてるんですが、個人的にはこのスタイルより、ここに出す方が好きなので、これ P キーを押すとオンオフがショートカットで割り当てられています。これ使ったことねえな。
Or, deformed in any way. And the primitive type set to polygon, uniform scale, it's up to you, and frequency set to 7, just because we need our mountain node to displace it and sort of create a rock. So you can see I have different rocks here if I go through the mountain nodes. And absolutely crucial is to UV them.
ラップとフォトシームがついてる。なるほど。
Because we will be using normal maps and all that stuff to create them more realistic. And here I'm using labs, and labs is here you can see I have in shelves you can install Houdini labs. or you can use UV unwrap, UV texture, something. Basically what auto UV does, UV unwraps your mesh, and in this way this unwrap is looking okay. I mean, not the best one, but yeah, definitely works. And then you plug them all into the merge node and you have this ugly looking thing, but yeah, then we just drop a null. It's called out rocks, and that's it for our rocks. You can create, I don't know, 20 different rocks, or just stick with 3 of them.
このキーストロークのアプリが見えないんですよね。打つときはちゃんと出てくれるんですけど、シフトオルト周りがなぜかこのマウスキーからの近くにすげえちっちゃく出るっていう。これを試した中だと一番これが具合良さそうなんですけど、ここにもこのシフトオルト表示周りだけがで、これ例えばなんかまとめてマージするときとかは全選択してオルトを押しながらやるとワッと出るんで便利です。
Completely up to you. So now, when we have our rocks, let's go and create our actual simulation. So
これをこねこねやるか。組み合わせる意味あんのかな。
absolutely crucial is map. Yeah, ugly looking things. And that's it for our rocks. You can create, I don't know, 20 different rocks or just stick with 3 of them. Completely up to you. So now, when we have our rocks, let's go and create our actual simulation. So for your convenience and for my convenience and to please my OCD, everything is in these boxes, so it's easier to understand what's where. But basically we start with our shape, and to recreate as track and else work, we obviously want a torus. You can create any shape, you can even get a human fillet with a rocks and then do something with that. Yeah, basically we start with the torus. Radius set to 2.5, the only thing that I modified from the default settings, and then I added the scatter, which scattered all these rocks here. You can use points from volume to scatter them inside the volume, inside the torus, but I don't think it's necessary. For now, let's decrease the total count to something like 300. It will be easier for us to understand. Then we need to scatter both rocks and both our spheres. What I need to do here is, let's say we want to scatter some rocks, and I dropped an object merge node, and what it does here in the object one, I should specify what object I should import, and in this case it's obj rocks out rocks. So you see we have our clump of overlapping rocks, and then we should drop a connectivity node, and what it will do, it will add a class attribute to every point. And then we also need to drop the attribute wrangle, and in this attribute wrangle I want to randomize the P scale, which will make some rocks smaller and some of them bigger. And to do that, I just want to write at P scale equals fit01, changes the value so it is in range of, in my case, 0.3 and 1. So basically I grab a random, which as you can see creates a random number between 0 and 1 from a seed, and our seed is at pt none, so every time it will be like random and different. And then I remap it to be not from 0 and 1 but 0.3 and 1, because we don't want these extremely small particles and your RBD will glitch and if you like feed something very small. And then I want to randomize the orient, so they are facing, they're rotating all different directions. And this cheers goes to Entagma, where I think they showed scattering the line in that tutorial. But this attribute from pieces, I wasn't aware of this node for a long time, but it's super cool. So basically what it does, if you write down p
scale でフィットで 0.3 から 1の P スケール突っ込んでオリエントを0.1の範囲で突っ込むと。でコネクティビティでクラスのアトリビュート作って スアトリビュートくる。
line in that tutorial, but this attribute from pieces, I wasn't aware of this node for a long time, but it's super cool. So basically what it does, if you write down piece attribute class here and set the mode to random, it will randomly pick one of our rocks. That's super cool. And then you just plug this attribute from piece.
クラスごとにランダムにしてくれるってことなのかな。クラス作って、こっちから入ってきたのがメインになって、このクラスを元にランダムってする。やってることはなんかトランスファー的なことをやってんだな。
Pieces into our copy to points, and look what we have. Cool scattered rock. Then
何これ。やってもやらなくても変わらねえぞ。やっぱそういうことか。クラスごとにランダマイズされてんのか。
let's scatter some spheres. So here I created my sphere. Obviously, yeah, we don't need this merge even and this connectivity. So then I just drop a attribute triangle. So
ほぼ変わらんな。
the same P scale and copy it to points. So yeah, we have our set of spheres right now. Super cool.
Scalar randomize かけてんだよ。
And copy to points. So yeah, we have our set of spheres right now. Super crucial thing here in copy to points is to check this back and instant. And despite that, after copy
ちはパックにするの。こっちもパックか。
into our copy to points, and look what we have. Cool scattered rock. Then
クラスにしてパックにするのか。ピース作ってパックと。
let's scatter some spheres. So here I created my sphere. Obviously, yeah, we don't need this merge. Alright, so that we want to that after copy to points is to check this pack and instance. And despite that after copy to points we are unpacking them, we should specify that we want to transfer all attributes in our unpack node. Alright, so let's get back to our rocks. So all attributes in our unpack node. Alright, so let's get back to our rocks. So now we want to set up the morph, and morph in this tutorial is done with attribute transfer. You can probably use mask from attribute, but I've tried that, and in this scenario I found it easier to set up with just a regular attribute transfer. So we need to colorize our rocks to be black, and then we set up a sphere, and I'll show you with a wireframe that it's here. We colorize it to be
どこにある？マスクかけようとしてんのか。トランスファー。カラーを転送するのかな。
be red, and then we transform it, and here you can see that I'm rotating colorize it to be red, and then we transform it, and here
ピボットずれてるからぐるぐる回るな。あれなるほどね。
Here you can see that I'm rotating the sphere. Every frame I'm rotating the sphere by the frame number divided by 2. So basically at the frame 30, the rotation of the sphere will be 15 degrees, and it goes like this. Then we can set up our attribute transfer, and you can see that if I plug
全部いっちゃう。ちょっととこれは広すぎる。ディスタンスレスカーネルレディアスって値がよくわ
like
からない。
our black rocks into the first input and red sphere into the second input, and I change the source and group type to points. Attributes, here in the points I set them to be CD, and conditions, kernel radius 5.8, distance threshold I set them to be CD, and conditions, kernel radius 5.8, distance threshold 0.32. You can see that we are colorizing. Alright, that's cool, but somehow we should morph them now. So we need to drop an unpack node, transfer all attributes. You can see they are unpacked, and now we drop an attribute wrangle, and here again I write down why we use linear interpolation and what it is. You can check out my
ああ、なるほどね。ここの部分にラープで持ってくんのか。カラーの値に応じてラープさせればいいって話か。大事にやるか。Pにラープで値をとこうなるよね。でも変換すると割とランダムなんだな。
My previous tutorial with a sphere consisted of these lines and affected by noise. Right now I will just briefly tell you what we have here. So here we will be morphing between our rock state and our sphere state. So basically here you can see that where we have our mask, we are interpolating from point position of rock and point position of sphere. So that's how our rocks become spheres. Again, more detailed explanation, you can find that in my previous tutorials. Then we need to pack that for
何これ？何でミスってんの？ストックスエラー。あ、これか。うん。で、つるんとしすぎちゃってよくわからんな。そうで、どうですか。なんかモーフィングの形状がおかしい気がする。こいつが違うか。どういうのか。ちょっと待って。いや、そもそも M アンダーバースケールってなんだ？わかんねえな。まさか P スケール。
You can find that in my previous tutorials. Then we need to pack that for our RBD simulation. So I'm using
ん？レッドの値が中途半端なんじゃないか、もしかして。やっぱそっか。 かしいなと思った。これ何してんだ。
Assemble node tutorials. Then we need to pack more detailed explanation. So basically here you can see that where we have our rock state and our sphere state. So basically here you can see that where we have our mask, we are interpolating from point position of rock and point position of sphere. So that's how our rocks become spheres. Again, more detailed explanation, you can find that in my previous tutorials. Then we need
ワンダーバースケールの説明がねえな。
to pack that for our RBD simulation. So I'm using assemble node and I'm transferring attributes P scale and M scale. And M scale is used further to animate the scale of the rocks and prevent any overlaps. And to be
そっか。シミュレーションの時に1フレーム目で計算されるからアニメーションデータが入ってこないってことか。
be fair, credits for this non-overlapping RBD fill thing goes to CGViki or Tokaru. I'll link that in the description and you can go and check his project files and articles and all that stuff. So from our assemble, we should create RBD geometry and we also should create RBD constraints that will keep our rocks in one place so they don't fly away. Let's start with the geometry because it's easier. So first of all, we should animate the scale, and not the P scale, but M scale, which basically is my scale. Yeah, and basically here in attribute wrangle, you see that I'm also linearly interpolating between M scale being 0 to 1.5, and this is because I want my spheres to be bigger than the rocks. So here I set the M scale, and then after assemble I drop an attribute wrangle and I animate the M scale to be multiply equal by this channel called scale. So basically what I'm doing here is, you can see here the scale is 0.114 and then frame 21 it's 1. So that's how you can animate them to be their default state. So that's basically they kind of grow, and then you plug that into another attribute wrangle, and you set the found overlap variable to be 1. Now let's set up tab constraints. From the Assemble tab, we draw an attribute triangle and we set the ID value of each point to be ptnum. And then from that attribute triangle, we drop another attribute triangle and set the name to be nothing, to be blank, because our RBD simulation will set up the names itself. And then we should merge our set ID and set name wrangle. Into the merge node, and then we drop an add. We add a points, and here you should select polygons. Yeah, actually we're adding polygons. You can check remove unused points, select by group, and add by attribute. Attribute name should be ID. And now we have everything to create constraints. So string
あるよね。
node, and then we drop an add. We add a points, and here you should select polygons. Yeah, actually we're adding polygons. You can check remove unused points, select by group, and add by attribute. Attribute name should be ID. And now we have everything to create constraints. So string variable.
これ今何してんの？アウトラインとかかけてみる。ここに数が増える。別だよな。空にしてんだ。どういうことだ？ここでネームを消して、パーティクル増やしたかっただけ。なんかコンストレント作ってる感じするんだけど、いまいちわからんな。まあいいか。
Variable called constraint name equal.
Constraint コンストレント作ってたのか。
equals pos, string variable at constraint type equals position, and rest length equals 0. So now we have everything to create our simulation in
そうだ、今んところこれ全部オーバーラップ1だよな。とかも入れずにオーバーラップって成り立つのこれ。
that variable to be 1. Now let's set up constraints, and you see they kind of grow, and then you plug that into another attribute. That's basically they kind of grow, and then you plug that into another attribute wrangle, and you set the found overlap variable to be 1. Now let's set up constraints. From the assemble tab, we .NET. So let's drop a .NET. And by the way, I was doing this on my MacBook, which is like M1 MacBook Air base level machine. I don't know. We have everything to create our simulation in .NET. So let's drop a .NET. And by the way, I was doing this on my MacBook, which is like M1 MacBook Air base level machine. I don't know how, but that MacBook was twice as fast as my laptop, which is ROG Strix Scars something with i7, 24 gigs of RAM and RTX 2070. Only thing there, and I thought it's might be helpful if you don't have like much RAM, you can limit the cache memory, because by default it's 5000, and you can limit it to be, let's say, 100 if you have not that much of a RAM and you're constantly like using swap and all that stuff. Yeah, and let me know in the comments if you want some comparisons between my main Windows machine and my MacBook, because at some point this thing surprises me. Alright, so back here in our .NET, not that much of things we can do, and we should do. So we start with dropping RBD packed object, and initial object type is set to create deforming active objects. Is super crucial, because without that it won't work, just simply won't work. Geometry source, first context geometry, because we are plugging that here into our first input. It's first context geometry. Override attributes is M scale because we want to actually like start with small objects and then we grow to our like this initial state. Initial state, inherit velocity from point velocity, bullet data, shrink collision geometry set to 0, collision padding set to 0, shrink collision geometry unchecked, and physical compute center of mass is also unchecked, geometry unchecked, and collision padding set to 0, shrink collision geometry unchecked, and physical compute center of mass is also unchecked. Then we also need pop speed limit and pop drag, and this is because we don't want our rocks to kind of fly very fast or spin without control, because again we don't have gravity, and you may saw all these fails of astronauts trying to catch their toothbrush or toothpaste, and basically the same physical scenario here. So we had a pop speed limit and maximum speed is set to 10, maximum spin is set to 3, and pop drag air resistance set to 0.4. In rigid body solver we plugged our RBD object to 0.4. In rigid body solver we plugged our RBD object into the first input and our pop speed limit and pop drag into the last input. So in rigid body solver, number of substeps set to 30, sleeping time set to 0. In constraint solver, constraint iterations set to 10, constraint solver parallel Gauss. Ensure islands are independent unchecked, constraint force mixing to 0.5. Yeah, I think that's all. So then we need to drop our constraints and actually make constraints for our, we need 0.5. Yeah. I think that's all. So then we need to drop our constraints and actually make constraints for our spheres and rocks. So we drop a spring constraint. Relationship. So here in data options, we need to set in the constraint data, we need to set strength to be 1000, rest length to be 0, and damping to be 10. And super crucial thing is here in data name, we should set our constraint name, which in our case is pos. And then we drop a constraint network. Constraint network is actually our second context geometry, which is here. constraint network is actually our second context geometry, which is here, RBD constraints, and we drop it into our second one. And basically from that, it already knows what to do, so we can hit play and boom. You see these red or yellow dots. These are our spring constraints.
明らかに挙動がおかしいな。ストレートネームミッシング。ストレートネーム。うん。名前がタイポかこれ。あ、ちげえ。まだダメだ。あれ合ってんな。八角入れんなとかそういうことか。ダメか。なんでだ。テキストジオメトリーでストレートネームイズビシわかんねえ。どっかのタイミングで急に消失するな。やっぱうまくいってないな。なんだこれ。データネームボス。これだよな。わかんねえ。なんだこれ。ガイドが出てないからうまくいってねえんだよな。 こうまくいかねえと思ったんだよな。これはわからんな。D が PD の入ってるまでは OK だ。これ同じ ID のものが2つできて、じゃあ、後で ID でID 同士つないでんだ。いや、タイプでもなさそうなんだよな。ここか。いや、これ2番目は入れるか。こっちか。コンスタントクリエイト。スプリング。入ってきた。ここに入ってきて。これじゃなくはなさそうだ。鍵かかってないからここまでか。手っ取り早くコンストレイント作れないかな。3つだよな。プリミティブじゃないよな。あ、プリミティブかもしかして。 プリミティブだったってこと間違えた。ということの持たせ方間違えた。プリミティブでよかったんだ。やっぱアニメーションしないな。にしても他のさすぎじゃね？遅っ。何これ。300とか180とか。これ遅すぎるな。こうやってるのかわかんねえ。45フレで90度。ってこと。見てんだ。大丈夫か。
Create our simulation in .NET. So let's drop a .NET. And by the way, I was doing this on my MacBook, which is like M1 MacBook Air. That and already knows what to do. So we can hit play and boom. You see these red or yellow. Yellow dots. These are our spring constraints. Here you can see that how it like expands, and here you can see how it contracts again. because those are springs. And here you can see that all of the overlaps are gone and our spheres are traveling to our torus. So after you are done with the .NET, you can drop somewhere elsewhere. You can drop a .import node, and here you specify your .NET and import style is set to fetch back geometry from .NET work. So then we obviously and import style is set to fetch back geometry from .NET work. So then we obviously unpack that, and here are two options for you.
どっかでバックなんかしたっけ。
What you can do is render out it with Redshift, or you can render it out somewhere else. Or you can use Mantra, but I don't know Mantra. So for me, in this case, it's easier to export that to Cinema 4D and kinda art direct it. It's just my personal preference because I worked many years in Cinema 4D and I'm trying to do these tutorials at least once a week, or I try to do them twice a week, and the speed of production really matters to me without sacrificing the quality of these tutorials. So many of you guys ask me in comments why I do that, but it depends from project to project. Sometimes I'm okay rendering with Redshift, sometimes it's really easier to set up all the textures and all that stuff in Cinema 4D for me. So basically what I've done, I've file cached that and then output ROP Alembic. If you want to go and render it out in Houdini, you can do the following. So you should promote the CD attribute from point to primitive. Then you
プロモートして。
can group by, let's say, red.
ダメだ。さっきのコンストレイントでめっちゃ疲れたな。 回かけちゃダメなんだっけ。
value more than 0, and let's say it will be a group 2, and then you can drop another group, and let's say CDR equals 0, so it will be another group. Then you can just colorize it whatever you want, or you can also drop one material, specify that it should be on the group 2, and you can drop another material, it will be on the group 3. If you want to follow me to Cinema
カラーつけて終わりか。こっちを外に出すか。
drop one material, specify that it should be on the group 2, and you can drop another material, it will be on the group 3. If you want to follow me to Cinema 4D, let's open it up and I will show you the scene setup. So here's my setup. Yeah, imported this alembic. So you drag and drop your alembic. It's super simple. Then I drop the material. So I have material of rock and I have some sort of specular material. And here in the mixer, by the way, you can click view and auto arrange selected and it will be kinda arranged. So we have our vertex map, which is here, our vertex color tag. You can use that to mix between the objects. So yeah, that's basically how I mix that. And yeah, super simple 3-point light system. One is like a top light somewhere here, and then another one is from that side, and this one is just a straight top light. And I rendered 2 passes, this one and then kind of like a close-up. So, and as usual, I'm using Fox Farm to render nearly every of my tutorials, and here you can see that I'm rendering 2 scenes, each 270 frames, and they were done in like, I don't know, like 10 minutes, and one of them cost me like $5, and another one cost me actually $10, but I assume that's because I'm using adaptive sampling, and here I got much more frame covered here, so yeah, it took a bit longer to render out. And if you also want to render cheap, fast, and with actually amazing quality, check out my affiliate link in the description. You can sign up and you will get extra coupon credits on your account, so you can test it out and see how fast and amazing this service is. So yeah, that's it for today. Thanks a lot for watching, and I really hope it was useful for you. And if you like this video, be sure to subscribe to my channel, and if you want to support me and see even more tutorials in nearest future, please feel free to check out my website for many useful assets and project files and setups. I'm sure you will find something that will boost your workflow. I'll be back very soon.
適当にやってみるか。はい。というわけで、一旦一通りレンダリングまで終わったので、今日はここまでにしたいと思います。ちょっとここをプリミティブにするっていうのを見落としてて、全然うまくいかなくて、だいぶハマりました。まあ、LINE 作ってんだから、まあ、それはプリミティブにするよな。気づくのがだいぶ遅れた。ここでアンパックしてるんですけど、なんかどっかでパックした、ここか。アッセンブルでパックしてるのか。アッセンブルでパックしたやつでシミュレートかけて、パックで戻してんのかな。まあ、パック周りがよくわかってないんだよな。あとはちょっとこのオーバーラップを設定したのもよくわかってないですね。多分 RDB オブジェクトにハンドオーバーラップがあるので、 昔は多分これに値を渡すためにやってるんだと思うんですが。これ M スケールなかったらどうなるんだろう。アニメーションしないんかな。スケールのアニメーションがなくなるだけか。変わってるか。アニメートスケールだから。じゃあゼロにしたら動かなくなるとか。なんだろう。ピースの名前変わらない。消してんだ。なんか、完全燃焼感が否めないな。まあ、この辺は別に全然いい。こっからだな。こっから下がな。ちゃんと理解できてないな。まあ、ここはちょっと要復習ってとこだな。はい。というわけで、後でちゃんとレンダリングしておこうと思います。はい。では、ご視聴ありがとうございました。